In this section, you will prove triangles congruent by SSS. So first of all, let's try and understand what the word congruent means. If you look at the first set of triangles, this one on the right here is much smaller than this one on the left. So if they are not the same shape, they're not the same size, and the corresponding angles are not congruent, then the two triangles are not congruent. And the way we indicate that is, this is the congruency sign, and if we put a slash, that means those two triangles are not congruent. By contrast, look at the two triangles below. So let's look at these two triangles. In these two triangles, all three angles are congruent, all three sides are congruent. That means all corresponding parts are congruent. Therefore, the two triangles are congruent because their corresponding parts are congruent. Triangles can be proven congruent by using the following methods, and this is certainly not the complete list, but these are the ones we will be using most commonly. SSS, SAS, HL, ASA, and AAS. S stands for the side and A stands for angle. So let's look at the two triangles here on the side. That's triangles XYZ and RST. And if you are given that segment XY is congruent to segment RS, segment YZ is congruent to segment ST, and segment XZ is congruent to segment RT, then you can conclude that the two triangles are congruent. Look at the way in which look at the order of the letters in each one. If you look at the congruency statement and you go from left to right, you can see that XY is congruent to RS. You can see that YZ is congruent to ST, and you can see that XZ is congruent to RT. And I really should correct myself. I should say segment in each case, because when I say XZ, I mean the measure of segment XZ. Look at this problem. You've got two triangles with a shared side, and the way you indicate a shared side is you put a S symbol sideways indicating they're shared. Ask yourself, are these two triangles congruent? Are the three sides congruent? Yes, they are. So we would say triangle LMN is congruent to triangle LPN. Check your congruency statement. Is segment LM congruent to segment LP, segment LM, LP? Yes. Segment MN and segment PN. Segment MN and PN? Yes. And is segment LN congruent to segment LN? It certainly is. So we have our three checks. In this diagram on the right hand side, you are given that segment WZ, let's go ahead and mark that, WZ is congruent to segment VX. Segment WY is this one, and segment VY are congruent. And similarly, you are given that segment YZ is congruent to segment YX. You also notice, or I also notice, that this side is common to the two triangles. So let me go ahead and see if I can prove the two triangles congruent. Let's go ahead and do our statements and reasons. So we'll do that here. So this is statements. and reasons. The first one, of course, is you write the given, which is from here. So I write given. Segment WZ is congruent to segment VX. Segment WY is congruent to segment VY, and segment YZ is congruent to YX. Okay, so I need three sides to be congruent, so let me just check my given. In my given, I see that WZ is congruent to VX, so this is one of the sides, so I'm going to check that. I can also see from the diagram that segment VW is congruent to segment VW, and this is reflexive property of congruency. Okay, the third side that I would want to prove congruent is segment VZ should be congruent to segment WX. I don't have that in the given. I'm not given it directly, but what I do see is that I'm given parts of VZ, segment VZ, and segment WX to be congruent. So let me see what I can do with that. Let me go back to my given. From my given, I can conclude that WX equals VY, and this is definition of congruency. I can also see that YZ equals YX. That's also definition of congruency. I'm sorry, this should be WY. That would be very helpful to me, WY. So now just look at 3 and 4. This is definitely going from 1. And in 5, if I add 3 and 4, so WY plus YZ equals VY plus YX. I'm just adding both sides of an equation, and this is addition property of equality. Think of, remember, WY, VY, YZ, YX all stand for numbers. So look at, let me just highlight this, WY and YZ. That doesn't really work, does it? So what should I do? And I'm doing this so you realize that sometimes you will go down the wrong path in a proof, and that's okay. You just go back and retrace your steps. So what I'm realizing is, instead of WY plus YZ, what I need is WY plus YX. Well, I can easily accomplish that if I go to number 4 and I go ahead and I'm going to cancel this very neatly, because that's exactly what you should do. If you've made a mistake, then I'm going to go to number 5 and I am going to say YX equals YZ, and when I switch things around an equal sign, that's called the symmetric property of equality. So let's try again. How about I try and add 3 and 5 this time? So I get WY plus YX equals VY plus YZ. So quick look at the the diagram. WY plus y-axis WX, and VY plus YZ is WZ. Okay, the difference between these two is number 6 is addition property of equality, and this is segment addition postulate. Segment addition postulate. So we have, now we can say segment WX is congruent to segment BZ, and this is the definition of congruency. So I can check, I have got one side congruent, two sides congruent, three sides congruent. So my two triangles are congruent by triangle, and I want to make sure I have them in the correct order. So let me just go back. VWX and WYZ. VWX is congruent to WVZ, and the reason is SSS, because I have shown that three sides of one are congruent to three sides of the other. So you've just shown two triangles congruent by SSS.